Hi there, today we will be exploring statistical analysis in the form of Pearson's correlation. Firstly, Pearson's correlations are used in statistics to measure how strong a relationship is between two variables. It is important to remember it only works for a linear relationship among two variables. The Pearson's correlation coefficient is commonly also represented by the letter R. The sign of the coefficient determines the direction of the correlation. So whether it's positive or negative, it determines the direction of the correlation. When the sign is positive, it's a positive correlation. When the sign is negative in front of the coefficient, it's a negative correlation. The value of the coefficient itself indicates the strength of the correlation. So the value of the coefficient equals to the strength of correlation between the tested variables. What the scale is, a weak correlation has a value between 0 to 0.3. A moderate correlation has a value between 0.31 to 0.6, and a strong correlation has a value between 0.61 to 1. The same scale is also used for negative values of the correlation coefficient, only there are negative ranges over here. A useful piece of information on when to use this form of statistical analysis is when you have, first of all, quantitative data, so numbers. The second condition is it should be a linear trend with the data you have, and you should have the aim for testing a correlation. So these are the reasons when you should use Pearson's correlation. Also, please remember, correlation does not equate to causation. This is very important, and I will go further into this in another video. Okay, so let's look at one practice example to strengthen our knowledge on this topic. So the example we have here is there is a 0.9 correlation coefficient between height and shoe size. What does this mean? Firstly, we know this is a positive correlation because the coefficient itself is positive. And we also know it's a strong correlation because 0.9 is in between 0.61 to 1, which means it is strong. Thus, we have a strong positive correlation. Now, to answer the question, relate back to the context of the question, which is given right here. Since we have a direct relationship, a correlation coefficient of 0.9 between the shoe size would mean as a person's height increases, there is a direct increase in their shoe size. And that there is the answer. Thanks for watching. I believe you have gained a stronger understanding of Pearson correlation statistical analysis. See you guys later.